Alright class, we are on to Unit 9. We're going to be talking about radicals, the Pythagorean theorem. We're also going to talk about special or right triangles and trigonometry. So it's a large unit that we're going to be covering. A lot of it will be a review over some algebra that we already know, such as radicals, as well as things that you probably have seen before, like the Pythagorean theorem, and covering new things, new concepts like special right triangles and trigonometry. So we're first going to start off with 4, talking about multiplying radicals. And this is like a preview to Chapter 9, things that you probably should know, but we're going to be reviewing. And so radicals are like square root 5, or radical 5, and the square root of 36. They are both radicals, but what is the difference? The square root of 36 is a perfect square, and perfect squares mean when a square root is a whole number. And so, like square root of 36, I get absolutely just 6. Whereas square root of 5, I probably would get a decimal. So, this first example, I want you to list the first 15 perfect squares. For example, I can start by going to square root of 4 and I get 2. Or I can always work backwards. So if I were to get 3, what is 3 squared? Well, 3 squared is 9. If I took the square root of 9, I get 3. And so on, I get 16 is 4. The square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. And so on and so forth. So I'm trying to get the first 15. So I have square root of 81 is 9. Well, what's 10 squared? 100. So square root of 100 is just 10. Then I have the square root of 121 is 11. What is 12 squared? Well, it's 144. And then 13 squared. That would actually be 169. So square root of 169 is 13. 196 is 14. And the square root of 225 is 15. So that is knowing the first 15 perfect squares, okay? And so these perfect squares are going to help you later on when we start simplifying. So not every square root is a perfect square. For example, we have the square root of 12. However, you might get a decimal answer. If I were to put in a calculator, I get a decimal answer of 3.46. I can also simplify this if I want to. And I can use this by using a factor tree. So I can use a factor tree. So what two numbers will go into 12? Well, I can do 4 and 3. And look, 4 is a perfect square because I go down to 2 and 2. Now this is where I use the concept of parents or couples going on a date and kids staying at home. So remember how we said that this I like to call a house. And so the couples or parents, they like to go out on dates. So they're actually going to leave. So I have one set of couples, and then the kids or kid in this case will stay inside the house. So square root of 12 is really 2 square root of 3. So that's just a little bit on simplifying, and we'll get back to that momentarily. So now we have seen problems like 3 square root of 5, very similar to this one, but we're going to work backwards. This would be the square root of 45 because 3 squared is 9, and there's already a 5 under the radical. So this is saying that if I were to square this part, so I would take 3 squared if I were to put it back underneath the radical, times the 5. Well, 3 squared is 9, and I still have 5 because they're being multiplied. 3 is being multiplied by 5, or 3 squared is being multiplied by 5 in this case. So I end up with square root of 45. So this is how they have 3 squared, and there's already 5 underneath the radical, and how these two are equal to each other. So I'm going to get examples 2, 3, 4, and 5 writing as a single radical. So we'll do what we did there. If I want to put this underneath the radical, I need to square it. So it would be 2 squared times 5. And so I get 4 times 5, and that is the square root of 20. Then I'll do number 3. So I have, like before, a 3 squared times 2. And that's the same as 9 times 2. It gives me the square root of 18. Simple enough? So let's see if I can do this. This is writing for a single radical. So I have 5 squared times 6. And 5 squared is 25 times 6. If I were to type that into my calculator, I have the square root of 150. And the last question, number 5, all underneath that radical, I'm going to square the 6 and multiply it by 7. So I have 36 times 7, and I get the square root of 252. Okay? So now, on the next page, we're actually going to do this, but going backwards. So this is putting it underneath a single radical, and now we're going to go work backwards from a whole radical, and we're going to simplify it at some point, okay? So, now with multiplying radicals, let's think of this example. We have, off the top, we have 2x times 3x. Well, normally we would do the 2 and the 3, and you get 6. And then we would do the x's. And so I get x squared. And this is how I end up with 6x squared. Okay? The same thing applies to radicals. So if I want to find the product, I just multiply what's the coefficients and multiply what's in the radical. So, for our first question, we have square root of 5 times the square root of 6. Well, I end up with the square root of 30. What if I wanted to simplify that? Well, honestly, this can't be simplified because I have 3 and 10. I need to find any pair. So let's see if I wanted to simplify this. So let's say I had back to 5 and 6. Then I have 3 and 2, and I'm still just left with 5 and 1. I don't have any matching pairs, so this just stays the square root of 30. So let's try number 7. So I have 3 times the square root of 8, 3 square root of 8, and so 3 times 8 gives me 24. Can I simplify this radical? Yes, I can. So what two numbers go into 24? Well, I can choose 8 and 3 again, or I can use 6 and 4. Any of those would work. I'm going to use 3 and 8 because I just multiplied them. Then I have 4 and 2, and I'm down to 2 and 2 and nothing but primes. How many sets do I have that are the same? I have 1 set. I have 2. So these parents are going to go out the house, and I'm left with 3 and 2 staying at home. And I'm actually going to multiply these together. So I have 2 square root of 6. And so square root of 24 is the same as 2 square root of 6. And you want the simplified form. You can also do the same with 8. You could just simplify 8. So that's one way to do it as well. Let's try number 8. So number 8, I would do my coefficients first. So 6 times 5, and I get 30. And then I have square root of 7 times square root of 2. It gives me square root of 14, which I cannot simplify. So I'm left with 30 square root of 14. Okay. Let's try number 9. So I have negative 2 times 5 is negative 10. And then I have square root of 6 times square root of 8. I get the square root of 48. But this is simplifiable. So let's simplify the square root of 48. So I'm left with 6 and 8 like I did before. And it with 3 and 2, 4 and 2, and 2 and 2 again. So do I have any matching sets? I do. I have 1 matching set here and 1 matching set here. So that means I'm left with 2 times 2 on the outside of my radical. On the inside, I'm left with my lonely child, which is just 3. Alrighty. And so, I have negative 2 Alright, so I'm left with negative 10 times 4 square root 3. And so I'm left with negative 40 square root 3. Alrighty, let's move on to the next one. Alright, our next one is still doing the same thing. I have negative 6 times a negative 8, which gives me a positive 48, and I have square root of 2 times square root of 2. Well, square root of 2 times square root of 2 gives me square root of 4. But what is the square root of 4? Square root of 4 is 2. So I'm left with 48 times 2, which gives me 96. Okay, on to number 11. I'm looking at 5, square root of 5 squared. And so this is the same, saying square root of 5 times the square root of 5, right? Well, square root of 5 times square root of 5 is square root of 25. But the square root of 25 is just 5. So think that the square root and your squareds cancel, and you're left with just on the inside. Okay, and do the same thing with 12. So I have my exponent, so I have 3 square root of 2 times 3 square root of 2, and I'm left with 9 square root of 4. But square root of 4 is 2, so 9 times 2, and I'm left with 18. Another way you can do this is you can distribute that exponent like you did in algebra. So I had 3 squared, and then square root of 2, and which is 2 in itself, so I still have 9 times 2, which gives me 18. So either way, these work. I'm all about options as long as it works for all. Okay? Now, number 13 is a little tricky because we're multiplying a fraction. Now, note we're only going to multiply going across. We're not cross multiplying like we did before. We are multiplying all the way across. So I'm left with the square root of 42 all over the square root of 189. Okay? Now let's see if these can be simplified. So I have 42, so I have 14 and 3 like I did before, and then I have 7 and 2. The square root of 42 simplifiable? It is not. So we're left with square root of 42. And if you wanted to do 189, I'm left with 27 and 7, and then 9 times 3 is 27. These are not simplifiable, so we're just left with 142, square root of 42 all over the square root of 189. Okay? So that's what we're left with. You can always check to see by any matching factors. Okay, and we have number 14. So number 14, again, we're multiplying all the way across. So I'm left with square root of 5 all over the square root of 36. But what is the square root of 36? Square root of 36 is just 6. So I'm left with square root of 5 over square root of 6. Note, when you have something like this, like 5 over 3, it can also be written as square root of 5 over square root of 3. Okay? Alrighty, let's go on to our next one. And this is dividing radicals. So page 5 is dividing radicals. So when you're dividing radicals, you're kind of applying the same logic. But if you are able to reduce, please do so before you simplify. So dividing radicals, I have square root of 3 over square root of 16. Okay, and I can't have, the one thing about radicals, I can't have radicals in the denominator. So no radicals in the denominator. And how we do this, if we have to multiply by the radical underneath on both sides. So I would do square root of 16 times square root of 16. Okay, so I multiply all the way across. And then I'm left with square root of 48 all over 16. Because you have square root of 16 times square root of 16, which is the square root of what its addition would be, and I'm still left with 16. So, is square root of 48 simplifiable? So let's look at 48 again. I have 6 and 8. I have 3 and 2, 2 and 4, and I'm left with 2 and 2. And so I do have matching pairs here, which is 4 square root 3. So this reduces to 4 square root 3 all over 16. And 4 over 16 does reduce. It reduces to 1 over 4, 1/4. So really this reduces down, simplified, to square root of 3 over 4. Okay, so walking through, you're multiplying by its denominator. You can't have a radical in denominator, so you must multiply. And then you multiply across. Then simplify if you have any radicals. And then simplify if need be, if there's a common factor between your coefficients. Okay, so let's do the same thing here. So I could do the same thing. However, note how we said if we were to write something this way, it is the same as this way. And what is 21 divided by 3? Well, that's 7. However, you must keep your radical. So you can always simplify. You can always divide first before simplifying. Okay, divide first before simplifying. Okay, let's try number 3. So number 3, let's see if I can reduce. I have 8 over 4, if I wanted to look at that. 8 over 4 does reduce to 2. So I have 2 square root of 48 all over square root of 2. But I have a radical in the bottom. I need to get rid of it. So I'm going to multiply by square root 2 on top and bottom. So I'm left with actually, I can reduce this. What is 48 divided by 2? So there's where I have no need to do this, because I have 48 divided by 2 already. So I do not need to multiply by the conjugate here, or by another radical. So I have 2 square root of 48 over 2, and 48 over 2 reduces to 24. So I have 2 square root of 24. However, is this reducible? Can square root of 24 be simplified? Yes, it can. So if I were to look at 24, I can use 6 and 4, left with 2 and 2, and 3 and 2. I do have a matching pair here, and so what goes on the outside is 2, and what goes on the inside are multiplied, which is 3 times 2. So I'm left with 2 square root of 6. And so, note these are being multiplied, so I have 2 times 2 square root of 6, and I'm left with 4 square root of 6. So 4 square root of 6 is my simplified answer. Okay, so now number 4. Number 4 is where we will have to multiply top and bottom by its denominator. So 12 square root of 2 is on top, and square root of 2 times square root of 2 is square root of 4, but square root of 4 is also 2. Now, I can simplify 12 over 2, which is 6. So 6 square root of 2 is my simplified answer. Alrighty, let's try the next one. So number 5. So I have square root of 3 all over square root of 7. I can't have radicals in the bottom, so I'm going to multiply. Multiply square root 7 over square root 7. So I have square root of 21 all over positive 7. No, I can't reduce this because our 7 no longer has a radical. It only works if it's all underneath the radical or not. So I'm still just left with square root of 21 all over 7. Okay? Alrighty, so let's do number 6. So I have square root of 5 over square root of 11. No, we can't have radicals in the bottom, so I must multiply by its denominator. So multiplying across, I have square root of 55 over the square root of 121, but the square root of 121 is just 11, so I'm left with square root of 55 over 11. Okay, so that is dividing radicals for page 9. And so you have quite a few practice pages here. Number 6, 7, and 8 are your practice pages. So you have 6, 7, and 8 6, 7, and 8 are your practice pages to simplify, okay, when dividing and multiplying radicals. Always make sure you can simplify. On page 9 is your Pythagorean theorem. And so I don't have a notes page for this because we all know that the Pythagorean theorem is a squared plus b squared equals c squared. And so make sure that you know where your c is going to be. It is always across from your 90-degree angle. Okay? And so that's your practice page, which is page 9 and 10. Okay? 9 and 10 are your practice pages for the Pythagorean theorem. And that concludes chapter 9 and chapter 9.0 and 9.1 notes. Thank you.